We're going to start the last section in Chapter 7, which is 7.6, Natural Logarithms. The first couple of examples we're going to use are properties that are the same from 7.5. They are also, or should be on the top of your worksheet for 7.6. So to start off with, we're going to simplify natural logarithms, or LN, which stands for natural logarithms. So for this first one, we have 2 natural log of 15 minus natural log of 75. To start off with, notice how there is a coefficient, so we're going to put that as an exponent. So we'd have 15 squared, and then so we use the power property, and then from there we can take 15 squared, which is 225, and then they are subtracting, so we need to go ahead and divide and use that quotient property. So then we're going to take 225 divided by 75 and get 3. So our final answer is a simple natural log is the natural log of 3. Over here, the next example, we have another coefficient, so we're going to use that power property. That goes as our exponent just for that second term. So we have the natural log of 7 plus the natural log of 5 squared. 5 squared is 25, so we can simplify that down. And then they are adding, so we're going to go ahead and multiply and use that product property. So 7 times 25, we get 175. So it would be the final answer, natural log of 175. We use the power property and the product property. From here, we have a couple natural logs that we want to go ahead and solve for. So for this one, we have the natural log of x minus 3 squared equals 4. So this is kind of like if it was in exponential form, we switched it to logarithm. If it was in logarithm, we switched it to exponential. For natural logs, though, if it's in natural log form, we switch it to base e to solve for it. If it's in base e, we switch it to natural log to solve for it. So for this one, we're going to go ahead and solve it by switching it to base e. So I always just kind of put an e here just to help me remember how to switch it into our base e form. So we have e to the 4th power equals then our x minus 3 squared. And then from here, this e to the 4th power, we're going to put that into our calculator, write that as a decimal. The e button is right kind of next to the 4. Notice it's above the ln button, so we need to click second and then that button. So we have e to the 4th power, and then I'm going to write that as a decimal, 54.598 equals then my x minus 3 squared. How we undo this to the 2nd power, we square root both sides. The square and the square root just cancel out, so we're going to have x minus 3. When we take the square root of both sides, we need that plus or minus sign. And then I'm going to take the square root of 54.598, and I get that 7.389. And then I need to get this x by itself, so I'm going to add 3 on both sides, so those cancel out. So then I have x equals 3 plus or minus 7.389. So to get my two answers, I'm going to have to take 3 plus 7.389, get my one answer, so 10.389, and then I'm going to take 3 minus 7.389 to get my second answer, which is negative 4.389. And we can round just to the hundredths place for both of those. Now the second example is the natural log of x to this equals 2. So we're going to switch it to base e. So we have e to the 2nd power equals x. This one the x is already solved for, or isolated by itself, so we just need to simplify this and put e to the 2nd power into our calculator to get our answer. So we'd have 7.39 if we round to the hundredths place. This next one, we're going to be solving them when they're in base e. So they're in our exponential form, they're using base e, so we're going to switch it to natural log to solve for it. Notice how the base e is not by itself, so we want to get it by itself before we switch it to a natural log. So we're going to subtract the 2 from both sides. Our 2's cancel out. So we get 4 times e to the 2x power equals 16 minus 2, or 14. And then it's 4 times this, so we're going to divide both sides by 4. So our 4's cancel out, so we have e to the 2x power equals 14 divided by 4 is just 3.5. And then from here, It's in our base e, or exponential form, so we're going to switch it to a natural log. So then to switch this, we just drop our e. So then we have the natural log of 3.5 equals our 2x. Or you could have 2x equals the natural log of 3.5. And then from here, we're going to put the natural log of 3.5 into our calculator. So the natural log button is right next to the 4. So natural log of 3.5 equals 1.25. So I'm going to plug that in. Equals 2x, so then I divide both sides by 2. Those cancel out, so I end up with 1.25 divided by 2, which is 0.63 if I round to the hundredths place. And over here, again, this is in base e, so we're going to switch it to natural log. So I just normally drop the e and bring my exponent down, so x minus 2 equals the natural log of 12. Or you can have the natural log of 12 equals x minus 2. Then from here, I'm going to put the natural log of 12 into my calculator, write that as a decimal, so 2.4849 equals x minus 2. Then I need to get this x by itself, so I'm going to add 2 on both sides, those cancel out. So I get x equals then 4.48. Now we're going to go through some more examples. So if you have it, you can get to your worksheet. If not, then keep following along with us for some extra examples of these. So for this first one, we have write as a single natural log. So they're in expanded form, so we want to use our properties. First thing I notice we have a coefficient, so that will go as the exponent of just that term. So we'll have 2 to the 4th power. 2 to the 4th power is just 16. So we'll have the natural log of 16 minus the natural log of x. So we use the power property to start with, and then they are subtracting, so we're going to use the quotient property and divide. So then we're going to take the natural log of 16 divided by our x. Then it's a single natural log, so that is our final answer. This next one, it says find the solution of the natural log of x plus 3 squared equals 10. It's a natural log, so we're going to switch it to base e. So I'm going to put an e here to help me remember that. So it's e to the 10th power equals x plus 3 squared. And then from here, I need to start getting this x by itself. So to start with, this e to the 10th power, I'm going to put that into my calculator, write that as a decimal. So I have 22,026.46579. So I'm going to put that in, and then equals x plus 3 squared. I need to start getting this x by itself, so since it's to the 2nd power, I'm going to square root both sides. The square and the square root will cancel one another out. I have then x plus 3 equals, and then whenever we take the square root of both sides, we need that plus or minus. So then I'm taking the square root of that number, so 2nd square root of our original number, and we get 148.41. And then from here, I need to get that x by itself, so subtract 3 on both sides, so those cancel out. So then I'm left with negative 3 plus or minus 148.413. So then from here, that plus or minus sign means that I have to add to get the one answer. So I get 145.41, and then I'm going to subtract to get the second answer. And then I get negative 151.41. Then the last one we're going to take a look at is in base e, so we're going to switch it to a natural log. So I have 2 times e to the x power minus 4 equals 1. Notice if any of these are in expanded form, we want to isolate them first, and then we can switch it to the other format. So I'm going to add the 4 to both sides. The 4's cancel out, so I get 2 times e to the x power equals 5. Then I need to divide both sides by 2. So I have e to the x power equals 5 halves, or I can just put 2.5. And then now it's in exponential form, so I'm going to switch it to natural log. So I'm going to just drop that e, and then it will be the natural log of 2.5 equals our x. And then the x is already by itself, so I just want to simplify this by putting in the natural log of 2.5 into my calculator and getting a decimal of 0.916 or 0.92 if I round to the hundredths place. So that would be my final answer.